Interpreting slope and y-intercept with linear equations. This is easily the most important skill in understanding and making meaning in the real world with the math that we're doing in class. The biggest idea is, if you don't already have it in your notes, is that the slope is always going to be our constant rate of change. And our y-intercept is always going to be the starting value of whatever situation we're talking about. That's the most important idea to get down. Your slope is your constant rate of change. Your y-intercept is always going to be your starting value. And when we need to know which number is which in an equation, you always know the number with the variable is the slope, the number that's all alone is the y-intercept. And the order doesn't matter. These are the same exact equation. The number alone is still your y-intercept. That 2 with the variable is still your slope. So now we're going to apply that to a real world situation. You are taking a road trip to New York City and you've already driven 120 miles and you continue to drive 65 miles per hour. There's the equation, y equals 65x plus 120. We need to write a nice interpretation sentence for the slope and for the y-intercept. So over here, I'm going to write down my equation and we need to label the variables. What are we counting here? And whenever you're a little bit confused, it's 5. Ask yourself, so I know I put 65 with the x, so go find the number 65 and see what idea is with it in the problem. And then we can start there at least. So it says you continue driving 65 miles per hour. So since we know it's 65 miles per hour, we know that that's 65 miles per hour. So x is counting the hours, and we know we're going 65 more, and we already went 120. So y is going to end up being the total miles driven. Now we need to put the pieces together. We know that the slope is your rate of change. We know the y-intercept is the starting value. We need to figure out, how do we start a solid sentence? You always start your interpretation sentence with whatever this alone variable is. Right now, y is alone. It counts for total miles driven. So my sentence must start with the total miles driven. Your sentence will always start with whatever variable's alone over here. That idea is the start of your sentence, the total miles driven. And you need to tell me, how does it start and how does it change? So we know the total miles driven start at the y-intercept. And this problem, that's the 120, since it doesn't have any variable. So the total miles driven start at 120, and that 65 is positive with the x, so we know that's going to be increases, and increases by 65 miles. But how often? Oh yeah, each hour. And there's our perfect, punctuation sentence. Example number 2. A computer repairman charges $60 to come to an office, plus 20 per hour. The total bill, B, and the number of hours worked, H, can be shown with the following equation. Now this problem helped us out. It told us what the B and H were. The total bill, B, so now I know B stands for the total bill that he is going to charge his person. The total bill. Then it also says, and the number of hours worked, H. So H will stand for our numbers of hours worked. Now that we have our variables labeled, we can start our sentence. The sentence always begins with this alone variable. Whatever variable's alone, that idea is the start of the sentence. The total bill. And now, like all good sentences, you need to tell me, how does the total bill start and how does the total bill change? Those are always the two ideas you're looking for in a good sentence. How does it start? How does it change? The total bill starts at whichever one up here is the y-intercept. 60 is your y-intercept because it's just a regular number. So that's how we know it's a starting value. $60. And now how does it change? That's a positive 20 with the H, so I'm going to say and increases by 20. And the H stands for hour, every hour. Always make sure you have the start and the change in your sentence.